This lesson has to do with quadratic inequalities. Remember when in Algebra 1, when you were talking about inequalities, you have less than, greater than, you also have the equal to. All of that's going to apply to a quadratic inequality. So what I want you to do first is with your calculator, let's go ahead and create, or let's go ahead and write our table. I went ahead and used a calculator to come up with the values, and now, since we know that there isn't an equal sign, we know that it's going to be hyphenated, and it says y is less than -4. So the values that we're looking for is anything that's less than -4. So it's going to be less than the inequality, okay, or less than the quadratic inequality. So it's going to shade. You're going to shade below. So any point that you select that is less than this inequality, or less than the parabola, will be the solution for this inequality. What you want to do is you want to graph this inequality, x squared plus 8x plus 20. You want to graph that first, and then you want to graph y equals 5. And you notice you have the inequality, you have the quadratic, and then you have the equation y equals 5. So it says x squared plus 8x plus 20 greater than or equal to 5. In other words, we want the y value to be greater than 5. So it appears to me that anything that's less than or equal to -5, and you can see -5, it gives you a y value of 5, -6 gives you a y value of 8, -7 gives you a y value of 13. It satisfies the inequality. Now, if we get numbers that are greater than, let's say greater than or equal to -3, you notice when x is -3, we still get a y value of 5, which satisfies the inequality. But you notice that anything that is greater than -3, in between -3 and -5, in between -3 and -5, doesn't give you a y value of 5. So you're probably asking, what is the solution? The solution will be less than or equal to -5. In other words, any x value that is less than or equal to -5, or x has to be greater than or equal to -3. Anything that's in between -3 and -5 will not work. Any number between -3 and -5, in between not including -3 and -5, will not work. So what is the solution? X is less than or equal to -5, or x is greater than or equal to -3. Will satisfy this inequality. So when I graphed this, I came up with the table. And remember that we want the values that are going to give me less than 0. Well, anything that is less than -3 gives me above 0. Anything above -2 gives me values that are greater than 0. So x has to be between, x has to be less than -2 and greater than -3. So it's going to be any number that is less than -2 or x is greater than -3. The solution in a compound inequality will look like this. X is less than -2, x is greater than -3. So you're looking at values between -2 and -3 that's going to give you anything less. So the numbers are going to be in between these two here. Example 3, we have x squared minus 10x plus 18 is less than or equal to negative 3. You're going to rewrite it as a quadratic, and that's what they did here. And then you're going to factor. And you're going to go through the steps of factoring. And you notice that you have x equals 3 or x equals 7, and we call those critical points. And that's going to help us to figure out what is the solution. So here is my critical points. Of course, we're going to say also equal. We're going to say they're equal. So we're trying any points that are to the left of 3, so we try 2. And we're going to try points to the right of 3, which we say 8. And those failed. The only one that worked is 4. So our answer is between 3 and 7. So just like our last one, I'm going to do a compound inequality. X is less than or equal to 7. X is greater than or equal to 3. And this is a compound inequality. Before we start, let's go ahead and divide this side by -1. Divide this side by -1. So what do we have? We have x squared minus 5x. We have to change the inequality, greater than or equal to 24. Now we are going to move the 24 to the left side. So we have x squared minus 5x minus 24 is greater than or equal to 0. We change this into a quadratic so we can find our critical points. So you got to find the factors of 24. And we know that the factors of 24, they're going to help us to factor this, will be x minus 8, x plus 3. So I know our critical points is x equal 8 and x equals -3. So make a number line. We have 0, we have -3, and this is a critical point. And there's a critical point. So we got to try 0. So we got to try 0. So we say, what about if the answer is between -3 and 0? What happens if the answer is after 8? So x equal 9. What happens if the answer is before -3? So we say -2. So we have to try numbers that are larger than 8, the critical points, in between -3 and 8, and also less than -3. So let's try 0. So we're just going to substitute 0 squared minus 5 times 0 minus 24, and that won't be greater than or equal to 0. So we know automatically that that 0 lies between -3 and 8. That's not going to work. So your answer has to be, let's try 9. 9 squared minus 5 times 9 minus 24 greater than or equal to 0. And if you evaluate the left side, you notice that 12 is greater than or equal to 0, so that's going to work. So you know that our answer will have to be larger than 8. It has to be larger than 8. In other words, numbers that are greater than 8. And now we're going to try -4. So we have -4 squared minus 5 times -4 minus 24 is greater than or equal to 0. And you're going to find out when you evaluate this that 12 is greater than or equal to 0. So that's going to work. So my answers are also going to be less than -3. They go in this direction. So if we wanted to write a statement, it'd have to be x is less than or equal to -3, or x is greater than or equal to 9. So that's our answer.